And hello, we're back to geometry. Hope y'all had a good weekend. Today we're going to start with section 1.8. 1.7 is constructions, which I think we need to do in class. So I'm going to skip over that section and we'll do it on Thursday. Also on Thursday, we will be having a vocabulary quiz. So you need to be studying your vocabulary words and the postulates and theorems for that. There may be a problem or two coming from the sections that we've done before as well. So make sure you're studying for that and you're ready for that. Okay, so let's start today. We're going to be talking about the coordinate plane. We did this in algebra, so you should remember. Let me get where you can see the board. Okay. Here I have the coordinate plane drawn. It looks better if it's on graph paper, but I didn't have any graph paper like this, so you should be familiar with this. We have the x-axis going horizontally, the y-axis going vertically, and then we have 4 different quadrants. They are numbered going counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in quadrant 1, both x and y values are positive. In quadrant 2, the x values are negative, but the y values are positive. Quadrant 3, they're both negative. In quadrant 4, we have positive x values and negative y values. So when a point is drawn in the coordinate plane, we have 2 numbers associated with them called coordinates. The x coordinate comes first, and that tells where it's positioned on the x-axis. And the y-coordinate comes second. So in the very center of where the x and y-axis cross, that's called the origin. It's labeled here with a point 0, and the coordinates are 0, 0. Here I picked another point, R, and it happens to have coordinates 4, 2, 4 on the x-axis and 2 on the y-axis. And down here is point T. It has coordinates of -3 for the x-axis and -4 on the y-axis. So you should remember that we plotted those points and did this in Algebra 1. And you may remember seeing the distance formula. We did use it also. So when we did the ruler postulate in the last section, we were able to use a ruler postulate as long as it was 2 points on a horizontal line or on a vertical line that we were measuring. So they were lying not diagonally in any way. It was always horizontally or vertically. We can still use the ruler postulate to find the distance then. But if we have 2 points like this, R and T, where they're not lying on a vertical or a horizontal line, then we need to use the distance formula. You're going to need to memorize this. The distance formula says for any 2 points, A and B, the distance between A and B is the difference of their x-coordinate squared plus the difference of their y-coordinate squared, and then those two added together and take the square root of that. So here A is x1, y1, and B is x2, y2. So when I plug things in, I'm just using coordinates, x-coordinates from the points, and then y-coordinates from the points. And I'm putting them into this formula and simplifying as much as I can. So let's look at an example of that. Let's just use these 2 points that we have up here. So I have the point R with the coordinates 4, 2, and T with the coordinates -3, -4. Now, if I'm following the formula, it might be helpful to label these. So underneath 4, I'm going to put x1, and underneath the 2, y1. And over here, this will be x2 for -3, and -4 will be y2. Now, I could have written those another way. I could have let T be the x1, y1, as long as I have them labeled so I make sure I plug them in correctly here. Okay, so when I plug them in, I'll have D equals the square root of -3 minus 4, all squared, plus -4 minus 2, all squared. So I'm just plugging in x2 minus x1 plus y2 minus y1. And those I'm going to subtract and then square. Then I'll add them together and see what I can do to simplify. So -3 minus 4 will be -7 squared. And -4 minus 2 will be -6 squared. Okay, and so continuing to simplify, we'll have -7 squared is 49, plus -6 squared is 36. When I add those together, I'm going to have the square root of 85. Now, since we're talking about distances, it would probably be good for you to go ahead and put this on your calculator and round it to the nearest tenth. Let me see what that would be. So that would be about 9.2. So make sure you pay attention to what they're asking you to round to when you do these problems. Let's do one where y'all can try it. So go to Quick Check 1. Pause this video and see if you can figure out the answer to Quick Check 1. Okay, you're back, I guess. And I'm going to work it out on the board so you'll have to know if you got the right answer. So for Quick Check 1, it says AB has endpoints, the line segment AB has endpoints A at 1, 3. I'm sorry, 1, -3. And B has the coordinates -4, 4. So these are the endpoints of my line segment, and they're asking me to find AB to the nearest tenth. Remember that when they say AB with no line above it, it means the length of line segment AB. So AB we're going to find the length of by doing the distance formula. So I'll just think of this first point as x1, y1, and then x2, y2, and I'll plug it in. So I'm going to do -4 minus 1 squared plus 4 minus a -3 squared. Now be careful with your signs as you go through. If I'm subtracting a -3, this becomes plus a +3. Right, so I'm going to have -5 squared plus 7 squared. That will be 25 plus 49, which will give me the square root of 74. Okay, here they asked me to round to the nearest tenth, so I'll use my calculator. I'll put in 74 and then hit the square root button. It gives me 8.6 if I round it to the nearest tenth. Okay, and the second part of Quick Check 1 asked, said suppose you let -4, 1 be x1, y1 and 5, 2 be x2, y2. Do you get the same result? And that was in, they were looking back at example 1. All they did was, instead of using t, which had the coordinates 5, 2 as the first point, x1, y1, they swapped and let the other one be the same value. I mean the x1, y1. And they wanted you to work it out and see if you got the same result. You should get the same result, which was 9.5. The order of the points doesn't matter. I can always let this one be x2, y2, and this one be x1, y1, and it will give me the same result, because when I subtract and then square it, if the signs were different, the squaring makes everything positive. So it doesn't matter which order you do the subtraction in. Okay. Some of you might like to stop right here and go work on the problems in your homework that are from example 1 or example 2. They will be like these problems that we've been working. If you want to do that and go and then come back and watch the rest of it, sometimes that's a great way to get your homework done quicker, because you're working on problems of the same type. So if you want to do that, go ahead, and then come back. Okay, the next thing that we're going to talk about in this section is how to find the midpoint of a line segment. So again, if we found the midpoint using the ruler postulate in one of the sections earlier, and that's okay as long as you're on a horizontal line or a vertical line. But again, if that's not the case, then I need to know how to find the midpoint. So if you think of a line segment that's going diagonally, we'll call this TS, and maybe we even have the points, the coordinates for these. Let's say 4, 3, and S is 8, 5. I need to know how